Alrighty, here is your key to the review. I'm going to start out by graphing exponentials. So what I always expect here is that you write the parent function. So the base of that exponential is 1/3 to the x power. Your little sketch. It is decay because that's a 1/3, so it looks something like that. I have 1, 2, 3 transformations. That negative is a reflection in the x-axis. That 1 means I go to the right 1. 4 means I go up 4. Okay, so the first thing I always want to get on my graph is my asymptote for an exponential. The parent function asymptote's here. The only thing that affects the asymptote is a shift up or down. So I would shift up 4 to get here. And then that means that my asymptote is at y equals 4 because it is a horizontal line. Figure out my anchor points. That's why this sketch is important here. All of the exponentials are going to start with 0, 1. So I'm going to put my pencil at 0, 1. I'm going to reflect in the x-axis and end up here. Go to the right 1. Okay, so then if x is 1, y is going to be 1/3. So start out at 1, 1/3, which is right about there. Reflect in the x-axis, I'm right here. Move to the right 1 and up 1, 2, 3, 4. Then when x is -1, y would be 3. Then I reflect in the x-axis, move to the right 1 and up 1, 2, 3, 4. Then I sketch in my curve, but ooh, that's bad. That's a little bit better. It looks something like that. So my domain for all of the exponentials will be -infinity to infinity. The only thing that's going to change is the range, -infinity to 4. And I'm going to say this again. Anytime you write an interval, you go left to right, bottom to top, least to greatest, least to greatest, least to greatest, oh my God, least to greatest. All right, y-intercept. I plotted it, it's right there, it's at 0, 1. It's increasing the whole time as x goes from -infinity to infinity, my y values are increasing the whole time. And then that means it's not decreasing at all. My end behavior, as x approaches infinity, f of x approaches 4. Then as x approaches -infinity, f of x approaches, we go this way, f of x approaches -infinity. Okay. All right, let's look at number 2. Another exponential, we got e here. So I'm going to write f of x equals e to the x. The base is greater than 1, so it looks like this. I have 1, 2, 3, 4 transformations. I'm going to have a vertical compression by 2/3. I'm going to have a horizontal compression by 1/2 because x is a liar. Then I'm going to go to the right 1. I'm going to go down 5. First thing I want to get on my graph is my asymptote. For the parent function, it's at y equals 0, but I go down 5, so I'm here at -5. Then my anchor points. I'm going to start with 0, 1. Put my pencil at 0, 1. I have a vertical compression by 2/3. So that changes my 1 to 2/3, which is right about there. Horizontal compression, x is 0, so nothing happens. I move to the right 1 and down 1, 2, 3, 4, 5. One thing I've noticed when you're having to estimate these is as you move, it's easy to kind of forget where you were in the space. So when you're here and we were at 0, 1 and we went to 2/3, see how I'm estimating, but I'm closer to the top than I am to the bottom. So when I move and count down, I still need to be closer to the top than I am to the bottom of the box. because as you count, I realize that it can move a little bit. All right, so then 1, when x is 1, y is e, which is about 2.7. So I'm going to go to 1 and about 2.7, which is right about here. I have a vertical compression by 2/3. So that's tricky when you don't have a calculator, but it's not that big of a deal. Multiplying by 2/3 is the same as dividing by 3 and multiplying by 2. So if I think of this 2.7 as 23, no. I think of 2.7 as 27. 27 divided by 3 is 9, and then 9 times 2 is 18. So instead of at 2.7, I am now at 1.8. And then a horizontal compression by 1/2, so I'm about right there. Then I'm going to move to the right 1 and down 1, 2, 3, 4, 5. And I did not mean to make a dot there. Okay. So then when x is -1, y is 1 over e, which is about 0.4. So I'm going to go to -1, about 0.4. Vertical compression by 2/3 is less than 0.4, so it's like right there. Horizontal compression by 1/2. Move to the right 1, down 1, 2, 3, 4, 5. Okay, so that's, I mean, they're kind of small and they're kind of stuck together, but that's what it should look like. It's going to look something like that. All right, my domain is still -infinity to infinity. My range, I start at -5 and go to infinity. Y-intercept, I have one, but I didn't graph it, so I'm going to have to go calculate it in just a second. We'll come back to that. My asymptote is that y equals -5. As x increases, y also increases, so it's increasing the whole time between -infinity and infinity, which means it's not decreasing. Then as x approaches infinity, f of x approaches infinity. And as x approaches -infinity, f of x approaches -5. So I still have to go find the y-intercept. So my y-intercept is when x is 0. So my y is going to equal 2/3 times e to the 2 times, well, when x is 0, that'll be a -1 right there, minus 5. Okay. So now I'm just going to simplify this, and that's going to give me y equals 2/3 times e to the -2 power minus 5. And that's really the best I can do there. So this is 0, 2/3 times e to the -2 power minus 5. And sometimes our exact answers look icky, and that's okay. All right, so number 3, we're moving on to the logs. So when you're graphing, if you did well on both of them, or even if you didn't, just don't get them mixed up and what you're supposed to do where. So for the logs, I'm going to write down my parent function. This time, instead of putting f of x, I'm going to put y. So y equals log base 1/2 of x. That's my parent function. I'm going to rewrite it as an exponential. So that gives me 1/2 to the y power equals x. And then I'm going to make myself a little chart because I choose for y here and I don't want to get them mixed up when I'm graphing. So if y is -1 for this would be 2, and then be 1, and then 1/2. So those should be always really be easy to figure out. I have 1, 2, 3, 4 transfer functions. That negative is going to be a reflection in the x-axis. The 3 is going to be a horizontal compression by 1/3. The 1 means I go the left 1, and that other 1 means I go up 1. So the first thing I want to put on here is my asymptote. Now this is a log. My parent function for a log, depending on whether this is greater than or less than 1, either way, whether it's going to look like this or look like this, you have a vertical asymptote here. The only thing that's going to affect it is a shift left or right. We shift to the left 1. So here is where my asymptote is. Then these are my anchor points. So I'm going to start at 2, -1. I'm going to reflect it in the x-axis. Horizontal compression by 1/3. Well, my x value is 2. I multiply it by 1/3, I get 2/3, which is about right there. Then I move to the left 1 and up 1. End up right there. Then I'm at 1, 0. Reflection in the x-axis takes me nowhere. Horizontal compression by 1/3. X is 1, so it becomes 1/3. Then I move to the left 1 and up 1. I'm right there. Then 1/2, 1 gives me right here. Horizontal compression by 1/3. So 1/2 times 1/3 is 1/6. So I'm really, really close there. Move to the left 1 and up 1. Oh, I didn't reflect. Dang it. Okay, so let me start over. I was so worried about the fraction here. I'm at 1/2, 1. I've got to reflect. So that's what happens, and that's what's going to happen to you sometimes. You're like, oh, that point makes no sense. So I realized what I did. So I'm at 1/2, 1. I reflect in the x-axis. Horizontal compression by 1/3, so that gives me to 1/6. Move to the left 1 and up 1. So I'm like really close right there. This point probably could stand to be to the right a little bit, but I don't know why I chose two that were like, the points are really small and really close together. All right, so my domain, negative, it's not negative infinity to infinity like it was on the exponentials. I'm starting at -1, going to infinity. My range, negative infinity to infinity. Okay. My x-intercept, so that's this point right here. So we can think about it a couple different ways. I'll give you the reasoning way through it, and then I'll actually calculate it in case the reasoning part doesn't really make sense to you. But when we were here at 1/2, 1, and I reflected, then this 1/2 became 1/6. So when I move over here and come up here, I'm 1/6 away from -1. So 1/6 away would give me -5/6, 0. Like I said, I'll work it out for you here in just a second too. My asymptote is at x equals -1 because it's vertical. It's increasing the whole time, but that's from -1 to infinity, and it's not decreasing at all. Then my end behavior as x approaches infinity, f of x approaches infinity. And then as x moves to the left, it doesn't approach in negative infinity, it approaches -1 from the right, and f of x approaches negative infinity. Okay. All right, so the math behind getting the x-intercept. The x-intercept is when y is 0. So 0 equals negative log base 1/2 of 3 times x plus 1 plus 1. Okay, so I'm going to subtract 1 from both sides. That's going to give me -1 equals negative log base 1/2 of 3 times x plus 1. Then I'm going to multiply both sides by -1, so I get 1 equals log base 1/2 of 3 times x plus 1. So I have my log isolated, so now I'm going to rewrite it as an exponential. 1/2 to the first power equals 3 times x plus 1. Okay? So 1/2 to the first power is just 1/2. I'm going to divide by 3. Dividing by 3 is the same as multiplying by 1/3, so that gives me 1/6 equals x plus 1. Then when I subtract 1 from both sides, I'm going to need a common denominator, so that's going to be 6 over 6. So 1/6 minus 6 over 6 is going to give me -5/6 equals x, which is what we already had. Okay, we good? All right. So we got another natural log. And I'm going to write y equals the natural log of x. Rewrite it, e to the y equals x. Make my little t-chart here. -1, 0, 1. So I know that e to the first power is about 2.7. Anything to the 0 power is 1. The reciprocal of e is about 0.4. Okay, things you need to know. 3 transformations. I have a vertical stretch by 7/4. I have a reflection in the y-axis. And I'm going to go down 3. I have a vertical asymptote for a log. I don't have any shifts left or right, so it's right here at x equals 0. My first anchor point is going to be at about 0.4, -1. I have a vertical stretch by 7/4, so my y value is -1. It becomes -7/4, which is like -1 3/4. I reflect in the y-axis, so I'm over here. Then I go down 1, 2, 3. Then I start at 1, 0. Vertical stretch doesn't do anything. Reflect in the y-axis, I'm over here. Go down 1, 2, 3. Go to 2.71. Vertical stretch by 7/4. So that's like 1 3/4, which is about right there. Reflect in y. Go down 1, 2, 3. Okay, so my graph looks something like this. Domain, -infinity to 0. Range, -infinity to infinity every time. My x-intercept, I have one, but I'm going to have to go figure it out in just a second. Asymptote is at x equals 0. It is decreasing the whole time, so I have none here, and it's decreasing from -infinity to 0. In behavior, as x approaches, so it doesn't approach infinity, it approaches 0 from the left. F of x approaches -infinity, and then as x approaches -infinity, f of x approaches infinity. Okay, so let's go back and find this x-intercept. X-intercept is when y is 0. So 0 equals 7/4 times the natural log of -x minus 3. So I'm going to add 3 to both sides. So 3 equals 7/4 times the natural log of -x. I'm going to multiply by the reciprocal. So 3 times 4/7 is going to be 12/7. That's equal to the natural log of -x. Rewrite it as an exponential. My base is e. So e to the 12/7 power equals -x, which means x equals -e to the 12/7 power. This is -e to the 12/7 power 0. Right? There are your graphs. All right, so now we're going to rewrite logs into exponential form and exponentials into logs. And it literally says rewrite. There is nothing to solve, okay? The base of the log becomes the base of the exponent, 3. Then you go around the equal sign, 3 to the 4th, keep going around, equals 81. So here I'm going to have 1/2, and I need that in parentheses to get my exponent to the -5 power equals 32. The base of this log is e, so this is e to the 2.08 power equals 8. All right, so now we're going to rewrite exponentials into logs. So the base of the exponent becomes the base of the log. So log base 4, and you go around the equal sign again, of 128 equals 7/2. All right, so I don't write log base e. A log with base e is a natural log. And again, this is a lowercase l and a lowercase n. It is not an I. It's not in. It's natural log. All right, so natural log, and you go around of 54.6 equals 4. Then here, the base here, log base 10. You don't actually write the base. It's just the log of 10,000 equals 4. So now these next ones say to evaluate. So evaluate means I want an actual answer. You're not just rewriting stuff. So I'm going to set it equal to x, so I have a variable. And then I'm going to do what I did on these other ones, is rewrite it. I'm going to rewrite it as an exponential. 4 to the x power equals 1. Well, I need common bases, so 4 to the x would equal 4 to the 0 power, so x equals 0. Then this equals x So I'm going to have 1/5 to the x power equals 625. I want to get common bases. I think I'm going to go with 5. So this would be 5. To get 1/5 to 5, that's a -1. So this will be 5 to the negative x power equals 5 to the, well, 5 times 5 is 25, times 5 is 125, times 5 is 625. So that's what I get. Then I use my 1-to-1 property, negative x equals 4, so x equals -4. Then I'm going to rewrite this. I'm going to get 12 to the x power equals 6. So I can't get common bases here, but it says evaluate the following, use the change of base formula when necessary. So I wrote this out, but it doesn't work for me. So I'm going to go back up and look at this, and the change of base formula, it's going to give me a log over a log, common log, and the base goes on the bottom. So this is log of 12, log of 6. Then you would use the calculator. And if I type in log of 6 divided by the log of 12, I get a big old long decimal, but I should always be accurate to 3 decimal places unless it doesn't make sense or I'm told otherwise. My answer is 0.721. All right, number 16. I'm going to rewrite this. So I'm going to get 8 to the x power equals 61. Once again, I'm not going to be able to get common bases, so I'm not going to do it that way. I'll use the change of base, which is going to give me a log over a log. The base of this log goes on the bottom, the other part goes on the top. Type that into your calculator, and I'll get log of 61 divided by the log of 8, and that gives me 1.977. Okay. All right, let's look at condensing. Okay, so to condense them, I need to know my log properties and what I can do with stuff here. So the first thing I know I can do here is to make 4 an exponent. So this is going to give me log base 3 of x to the 4th minus, and then that 2 can become an exponent, log base 3 of y squared. Now I'm subtracting 2 logs with the same base. That becomes 1 single log with that base. And then the 2 arguments get divided, so I get x to the 4th over y squared. All right, so on number 18, I got a couple options. I could combine these first and then worry about the exponent, or I could distribute this. And I think I want to distribute this. This will give me 1/3 times log base 7 of 64 plus 2/3 log base 7 of 27. All right, so now when I use my power property or my power rule, this 1/3 becomes the exponent up here. So 64 to the 1/3 power is the same as 64, or the cube root of 64, which is 4. So this just becomes log base 7 of 4 plus, and then this 2/3 would become an exponent on the 27. So that's the same thing as taking the cube root and then squaring it. Well, the cube root of 27 is 3. You square that and you get 9. So this is log base 7 of 9. Now I'm adding 2 logs with the same base, and it's going to be multiplied together. So that just gives me log base 7 of 36. All right, I'm going to go ahead and distribute this 1/2. So this is going to give me 1/2 times the natural log of 64 plus 5/2 times the natural log of k. And then that 1/2 does not get distributed over here, but this 4 can go ahead and become an exponent, so it'll be minus the natural log of m to the 4th. Right. So then I'm going to use this 1/2 becomes the exponent up here, so 64 to the 1/2 power is the square root of 64, which is 8, plus this 5/2 becomes an exponent on k, so plus the natural log of k to the 5/2 power, minus the natural log of m to the 4th. So then I'm going to combine these two, and I will get the natural log of 8 times k to the 5/2 power minus the natural log of m to the 4th, subtracting 2 logs with the same base, so that becomes one single log with division, 8k to the 5/2 over m to the 4th. All right, so number 20, I'm going to make this an exponent up here. So this becomes log of, and then when I square this does not become x squared plus 16. This becomes x squared minus 8x plus 16 plus log of 3x. So I'm adding 2 logs with the same base. I multiply, so that's going to be the log of 3x times x squared minus 8x plus 16. Then I'm going to distribute that, so that gives me log of 3x cubed minus 24x squared plus 48x. And all of those parentheses are important. Okay. All right, next page. So now I'm going to expand them as much as I can. So this log base 2 of the cube root, that's going to become log base 2 of 4x minus 5 to the 1/3 power. I use my power rule, that comes out in front, and I get 1/3 log base 2 of 4x minus 5. Okay, I can't do anything else with this because this is not, it would have to be multiplication for me to split it up. That is it. I'm done. All right, so number 22, I've got division, so I'm going to split that into subtraction. So this is going to give me log base 4 of the numerator, which is 3a to the 7th times c, minus log base 4 of 5. So this is as much as I can do with that part, but here I can expand this into 3 separate ones because it's all being multiplied. So this is going to give me log base 4 of 3 plus, and then when I get log base 4 of a to the 7th can come out in front, 7 log base 4 of a plus log base 4 of c minus log base 4 of 5. Okay, number 23. Now, you could go about 23 one of 2 ways. I'm only going to work it one way. The answers in the end do look different. So like if you were to distribute this cube into all of this, it would look different in the end, but that's a lot of, I wouldn't do that. I would just bring the 3 out in front. So this is going to give me 3 times the log of 5, and I'll make that u to the 1/2 power divided by w squared. Okay. So then that gives me 3, and then I'm going to split up the subtraction. So I need parentheses here because it's 3 times all of that. Log of 5u to the 1/2 minus log of w squared. Then 3 again, parentheses. I'm going to split this into 2. So this will give me the log of 5 plus, then it'll be log of u to the 1/2. So I'm going to go ahead and bring the 1/2 out. I could have written this out, the 2 out here when I did that part, I just didn't. And then minus, bring that 2 out front, 2 log w. But then I need to distribute my 3 to finish that up. So this gives me 3 log of 5 plus 1/2 log u. Oh no, it doesn't, because it's supposed to multiply by 3, like I just said. So 3 times 1/2 is 3/2 log of u minus, then 3 times 2 is 6 log of w. And that is my final answer. All right, on number 24, for me to be able to expand this, I don't get to chop it into 3 pieces here because I can't do anything with subtraction, but if it's multiplication or division, I can split it up. So what I need to do here is factor this. So if maybe you need to go off to the side to factor. 3 times negative 8 is negative 24, right? Two numbers that multiply to give you negative 24, combined to give you negative 2 would be 6 and 4. So I'd have 3x squared minus 6x plus 4x minus 8. I can factor out of 3x. That leaves me with x minus 2. And then I can factor out of 4. And that leaves me with x minus 2. So when it all gets finally factored, that would give me the natural log of 3x plus 4 times x minus 2. So now that I have that factored, I have multiplication here, so I can split it into 2 logs, and I get the natural log of 3x plus 4 plus the natural log of x minus 2. And then that is my final answer. All right. Now we're going to solve each equation and check for extraneous solutions because we are solving logs. So I've got 2 logs, same base, set equal to each other. So I can use my one-to-one property, and since the 2 logs are equivalent, these 2 pieces have to be equivalent. So 3x squared plus 4x has to equal 2x squared plus 12. So I'm going to subtract 2x squared from both sides. That leaves me with x squared plus 4x equals 12. That's a quadratic, so I set it equal to 0. X squared plus 4x minus 12 equals 0. Then I factor. My 2 numbers are going to be a positive 6 and a negative 2. So my possible x values are negative 6 and 2. And I say possible because we have to check for extraneous solutions. I take this negative 6. I substitute it in here. 6 squared is 36. 36 times 3 is going to be more than whatever 4 times negative 6 is, so I'm fine. Take the negative 6 in here and square it. That'll make everything positive, so that one works. Since everything's squared and positive, the 2 has to work, so both of those are my answer. Okay. All right, so now on number 26, I have all of the bases of the logs are the same, but in order for me to use the one-to-one property, I have to have a single log on each side, so I'm going to need to condense this. So I have 2 logs with the same base that are being subtracted. That would give me log base 9 of 12 over k minus 5, and that's equal to k plus 6. Oh, not just k plus 6, dang it. Log base 9 of k plus 6. All right, so now I have 2 logs with the same base set equal. That means that their arguments have to be equivalent. Use the one-to-one property. That'll give me 12 over k minus 5 equals k plus 6. Multiply both sides by the denominator, so I get 12 equals k plus 6 times k minus 5. Right, so I'm going to move up here, and then I'm going to multiply those. So 12 equals, that'll be k squared. Then I'll have minus 5k plus 6k, which will be plus k, and then minus 30. Set it equal to 0, so 0 equals k squared plus k minus 42. Then I need to factor. My 2 numbers are going to be a positive 7 and a negative 6. So my possible k values, negative 7, positive 6. Check these. I go back to my original. So this negative 7 in here, negative 7 minus 5 is negative. And whatever I get in here has to be a positive number. So that doesn't work. Let's say it had worked in here. If it had worked in here, I would still need to check this one in which it doesn't work over here. But it's possible to work in one and not the other, whatever. But once it fails once, it's just done. So then I check the 6. 6 minus 5 is a positive 1. I'm good. There's nothing to check here. That's positive. So my answer in the end is just k equals 6. Okay, so in order for me to get a single log on each side here, I need to condense things. I could make the could make the exponent, this 1/2 an exponent here, but I think I'd rather hold off on that so I don't have to take the square root of this just to see what happens here. So I'm just going to leave it like this for a second. So 1/2 log base 5 of 5c minus 9 equals, now I have two logs with the same base, so I multiply, so it'll give me log base 5 of 6. All right, so if I multiply both sides by 2, I can move that over here, and then 2 could be the exponent on my 6, and I think I like that better. So if I multiply both sides by 2, then this just becomes 2 over here, right? Because if this is 2 over 1, it zeroes out. So then I'll have log base 5. Still can't use the 1-to-1 property yet because I have something out here, of 5c minus 9 equals, and then when I can bring this up on the exponent, I'd have a log base 5 of 36. So now I have two logs with the same base. I can make 5c minus 9 equal 36. I'll move up here. And I can add 9 to both sides, so I get 5c equals 45. So c equals 9. I check it in here. 5 times 9 minus 9 is definitely positive. That's my answer. Okay. Number 28, I'm going to isolate my log here. So I'm going to subtract 2 from both sides. So this will give me log base 8 of 7 minus 5w equals, so 11/3 minus 2. That's going to actually be minus 6/3. So 11/3 minus 6/3 is 5/3. So here you have the 1-to-1 property. Instead, I'm going to rewrite it as an exponential. So my base is 8. 8 to the 5/3 power equals 7 minus 5w. All right, so 8 to the 5/3 power is the same as taking the cube root and then taking it to the 5th power. The cube root of 8 is 2. 2 to the 5th, so it's 2, 4, 8, 16, 32. So that'll give me 32 equals 7 minus 5w. I can subtract 7 from both sides, and I will get 25 equals negative 5w. So w equals negative 5. Then I have to check it. Okay, so 7 minus 5 times w, well, the negative 5 times the negative 5 is a positive 5, so that works. Okay. All right, so I need to condense things here. I'm going to get the natural log of 2r minus 3 plus, when I take this 1/2 and make it the exponent, I'll get the natural log of 3. That equals 7. So then I can combine these and get the natural log of 3 times 2r minus 3 equals 7. So I can rewrite this in exponential form. E to the 7th equals, I'm going to go ahead and distribute as I rewrite this out, 6r minus 9. So then to get r by itself, I'm going to add 9. So e to the 7th plus 9 equals 6r. So r equals e to the 7th plus 9 all over 6. So then when I go to substitute this in, whatever e to the 7th is, that's a little less than 3. That's going to be a really big number. Plus 9 divided by 6, that's totally going to be bigger than negative 3. So that's my answer. All right, so last one of these. Once again, I could take this and make this exponent, then I have to cube this, but I think I'll just let him hang out there for a minute, see what else we could do with him. 3 times log base 6 of 2h squared minus 14h equals, well, 15 minus 9 is 6. So now I think I'll just divide both sides by 3, and I will get log base 6 of 2h squared minus 14h equals 6 divided by 3 is 2. So now that I have that, I can rewrite it in exponential form. 6 to the 2nd power equals 2h squared minus 14h. So that's a quadratic. That's going to give me 36. So I'll set it equal to 0. 0 equals 2h squared minus 14h minus 36. Then I'm going to need to factor. I have a GCF, that is 2. Gives me h squared minus 7h minus 18. And 0 equals 2. And then I have h and h, two numbers that multiply to give me negative 18, combined to give me negative 7, be negative 9 and a positive 2. So my possible h values are negative 2 and 9. So negative 2 in here, squared is positive, then negative times negative is positive anyway. 81 or 9 squared times 2, so that's 81 times 2 minus 14h. If you don't want to actually figure out those numbers, think about what you're doing here. This would be 2 times 9 times 9 minus 14 times 9, right? 2 times 9 is 18, so it's 18 times 9 minus 14 times 9, so that's clearly going to be a positive number, and they both work. Alrighty, last page. We're going to solve the equation and check for extraneous solutions, but these are exponentials, so I don't think that's necessary. All right, so we've got 1/2 squared times 4 to the 3d power equals 1. So I need to get this exponential part right here isolated. Well, 1/2 squared is 1/4. If I want to move it over here, I can multiply both sides by 4. So I'll get 4 to the 3d power equals 4 to the first power. Then I can use my 1-to-1 property, and 3d equals 1. So d equals 1/3. All right, so the next one. I was able to multiply both sides by or divide, either way you want to think about it, because there was just a value over here. But here I have an exponential over here as well. So I basically need all 3 of these to be the same base. I think we'll go with 3. So if I want to take 243, maybe it could be 9. So 9 times 9 is 81. That's not going to work. All right, so it'll have to be 3. So I'm going to take this 243 and make it the base of 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So it's 3 to the 5th power times, if this is 3, this becomes the power of the 1/9. I'm sorry, 3 to the negative 2 power gives me 1/9. And then there's already a negative u there. So negative 2 times negative u is just 2u. And then that equals, I'll have a 3 here. That would be 3 cubed, so it's 3 to the negative 15u power. Okay, so all 3 bases are the same. Now remember, if you're multiplying 2 things with the same base, you add the exponents, just like you've been doing. So I get 3 to the 5 plus 2u power equals 3 to the negative 15u power. Now that I have a single one on each side, I can use my 1-to-1 property, and I get 5 plus 2u equals negative 15u. So this will give me 5 equals negative 17u, and u equals negative 5 over 17. All right. Okay, so number 33 is I have 18 to the 3n power equals, so I'm going to add 4 to both sides, be 53. I cannot get a common base here. So when I'm solving exponentials and I can't get a common base, this is where I use logs. So I'm going to take the natural log of both sides, or the log of both sides, it doesn't matter. I'm going to have the natural log of 18 to the 3n power equals the natural log of 53. I'm going to bring my 3n out in front. 3n equal, 3n times the natural log of 18 equals the natural log of 53. I want n to be by itself. So I can divide both sides by 3 natural log of 18. So n is going to be equal to the natural log of 53 divided by 3 times the natural log of 18. type that in your calculator. So you will have calculators for the part of the test that you need a calculator for, but you won't have one for the whole thing. You have to make sure that you can round correctly and know what that rule is, because I'm not telling you again. And this is your answer. Okay, so 34. I got to get my exponential by itself, that little part right there. So I'm going to move the 5 first. I'm going to get negative 6 times e to the x minus 2 power. When I add 5 to both sides, that gives me negative 139. Then I divide both sides by a negative 6, so that gives me e to the x minus 2 power equals 139 over 6, because that's the best I can do. So now that I have my exponential isolated, I'm going to take the natural log of both sides. So the natural log of e to the x minus 2 power equals the natural log of 139 over 6. Then the x minus 2 comes out in front, times the natural, and that's parentheses, times the natural log of e equals the natural log of 139 over 6. Well, the natural log of e is 1. So that just leaves me with x minus 2 equals this. So x equals the natural log of 139 over 6 plus 2. That's when you go to the calculator, do your thing on there, and x equals 5.143. Alrighty, so then here on 35, I'm isolating this. So I'm going to start by subtracting 5 from both sides. So I get 7 times 9 to the 2x, oh, that's not an x, that's an r. 2r plus 7 power equals 15. Then I'm going to divide both sides by 7, so 9 to the 2r plus 7 equals 15 over 7. So then I can take the natural log of both sides. So the natural log of 9 to the 2r plus 7 equals the natural log of 15 over 7. Then 2r plus 7 comes out here, times the natural log of 9 equals the natural log of 15 over 7. So now I'm trying to get r by itself, so I'm going to divide both sides by the natural log of 9. So 2r plus 7 equals the natural log of 15 over 7 over the natural log of 9. Then I'm going to subtract 7 from both sides. So 2r equals the natural log of 15 over 7 over the natural log of 9 minus 7. Then to get r by itself, you got a couple of options here, but if you're going to put all this in the calculator, it can be a huge nasty fraction, and that's totally fine. I'm going to divide this whole thing by 2. So I got the natural log of 15 over 7 over the natural log of 9 minus 7, all of that over 2. And you can type that in the calculator exactly like it looks, and it's no big deal. And you get negative 3.327. All right, on number 36, I have an exponential on both sides. It's isolated. I cannot get a common base here. So I'm going to just go ahead and take the log of both sides. So the natural log of 5 to the 2x minus 1 equals the natural log of 3 to the x plus 7. The exponents come out in front. 2x minus 1 times the natural log of 5 equals x plus 7 times the natural log of 3. So I can't just start dividing here. Since I have the binomials on both sides, I have to distribute. So I'm going to get 2x natural log of 5 minus the natural log of 5 equals x times the natural log of 3 plus 7 natural log of 3. So I'm going to get all my terms with an x on the left-hand side, everything else on the right-hand side. So I get 2x times the natural log of 5 minus x natural log of 3 equals 7 natural log of 3 plus the natural log of 5. Then from these two, I'm going to factor out the x. So I get 2 natural log of 5 minus the natural log of 3 equals 7 natural log of 3 plus the natural log of 5. Want to get x by itself, so I divide both sides by this, and I get that x equals 7 natural log of 3, 5 over 2 natural log of 5 minus natural log of 3. And I just put that mess in the calculator, and that gives me 4.386. Okay. All right, 37 and 38. Now remember, what's printed on the white paper that you have, those questions are bad. I gave you a little half sheet of green paper that had these questions on it, or if you got an updated printed one, maybe it's printed this way, but make sure that your questions look like this. If not, then you should have a half sheet of green paper to help you fix that. All right, so it says Kevin started his new job with a salary of $26,550 every year. So here's his initial. Every year, he receives a 3.15% increase in his salary. Write and use an exponential function to find his salary after 20 years. So this is going to be an f of t problem. My initial salary is $26,550, and it's going to be 1. This is an increase, so it's plus. And y'all, you have to know how to change percents to decimals. I cannot even tell you how many people miss things on that quiz because you don't know how to make a decimal out of a percent. I don't know how to help you with that. 0.0315 to the t power. That's us writing it. Then we are going to go and use it. We have to figure out what our time basis is. So it says it happens every year, and we're looking at 20 years. So I'm thinking t is years. So f of 20 then equals $26,550 times 1.0315 to the 20th power. Then you can put it in the calculator. Then your answer needs to be an actual statement that says Kevin's salary. Of course, it doesn't have to be this exact sentence, but something to this effect. Kevin's salary after 20 years will be, and then you got to use, dollar signs, and remember how to round things. We're talking money. Unless it says the nearest dollar, it is 2 decimal places because that's how we talk about money. It's $49,368.41. All right. So, and this was an increase. If it was a decrease, then that would be subtraction there. All right, so I have a 2018 Chevy Tahoe was purchased for $62,625. The vehicle depreciates at a continuous rate. So that continuous rate or continuously tells you that you're using the PERT formula. That's when you have to use E. The rate is 11%. Write and use an exponential function to find the value of the vehicle after 3 years. So it depreciates continuously, and then we're going to see what happens after 3 years. So A equals the initial amount, which is $62,625, times E to the rate. So the rate is 11%, so that's 0.11 times T, but this depreciates. And the way you do growth and decay with the PERT formulas, if it's positive, if it's growth, we want it to be decay, that has to be negative. Then I can actually put in the time, $62,625 times E to the negative 0.11 times 3. Put that into your calculator correctly. Then we can say the value of the vehicle after 3 years will be $45,022.60. Okay, there you go. I did forget to mention something on the graphs on the very front, so I'm going to go back to that because I saw this way too much on these quizzes that I graded. When you are doing these exponentials and you're looking for your transformations, one of the reasons that I have you write this here is so that you can clearly see that this 1/3 is part of the parent function. This is not one of the transformations. There were way too many of you that used the base of the exponent and tried to tell me it was some sort of transformation. That's one reason why you couldn't get your stuff done on your graph. Okay. Also, on any of these graphs, every single time I have ever done one of these with you, when I write these down, we do them in order from left to right. And if you do that and you're consistent every single time, you will do them in the correct order. If you don't write them in the right order, I am not going to take off for that. But some of you, you're not writing them in the right order, so I'm pretty sure you're not trying to graph them in the right order either, and that's why your graph doesn't make sense. Your shifts, vertical and horizontal, have to be the last two things you do, or what you're doing is not going to make any sense. Okay? All right, so do your best to be ready for your test tomorrow.